This is lesson 6-3, Analyze Rotations, and it starts in your workbook on page 322. This is example 1 on page 322. It says one feature of the new patio plan is a rectangular umbrella that can easily rotate so that clients can enjoy either the sun or the shade. Where should the architect move the umbrella to highlight this feature for his client? All right, so let's just talk a bit about some vocabulary. We know that the architect wants to rotate. So when you were younger and shorter, a rotation might have been called a turn. Now there's a couple of ways that you can turn or rotate a figure. If you're going this way, that is called clockwise. If you're going this way, it's called counterclockwise. All right, let's add a little bit more vocabulary. When you are rotating, it's important to have a pivot point. So I want you to think about basketball. So when you plant that foot and you pivot, that foot is not going to move. That is a fixed point, a pivot point, if you will. And it's called the center of rotation. So that's where everything is going to turn around. Then, one last piece of information is the angle of rotation, and that involves two things. It has to do with how much and which way. So on the last slide, we talked about which way, counterclockwise or clockwise. And now we're going to talk about how much. So I want you to think about a circle. If you go 1/4 of the way around a circle, that's 90 degrees. If you go halfway around a circle, that's 180 degrees. If you go 3/4 of the way around a circle, that is 270 degrees. And if you make a full rotation all the way around the circle, that is 360 degrees. All right, so if we go back to this architect scenario that we had, remember he has a rectangular umbrella that can rotate so the clients can either enjoy sun or shade. And so I wish they wouldn't have used a rectangular umbrella that sort of looks like a square umbrella, because that's hard to see how it's been rotated. But if you look at the first picture on page 322, there is a striped side to the umbrella. And you're going to notice that it went from the bottom and it rotated to this position. It is a quarter turn counterclockwise. All right, this is the try it on the bottom of page 322. The architect continues to rotate the umbrella in a counterclockwise direction until it is in its original position. What is the angle of rotation? So if you remember, counterclockwise, so that just means the opposite way that the clock hands turn, goes this way. And if we make the umbrella, and remember we had the striped section here to begin with, it's already moved here, right? It's got to go 1, 2, 3 more fourths in a counterclockwise direction. Well, on the last slide, I told you that 3/4 is the same as 270 degrees. Whoops, that degree took the place of my 0. 270 degrees counterclockwise. But if it had not said it had to be counterclockwise, we could have done 90 counterclockwise and also gotten it to the same position. So I want you to realize that we can go either counterclockwise or clockwise, and eventually we will get in the same position. But since they asked us for counter, we'll go with this answer. All right, this is example 2 at the top of page 323. What are the coordinates of the image of trapezoid ABCD after a 90-degree rotation around the origin? Okay, so there are 2 ways for you to do these rotations. One, you can take that clear see-through transparency, you can draw the original, and you can physically put a pivot point in and move it. So that's one option. But you're not always going to have the figure in front of you. Sometimes you're only going to have the vertices. So option 2 is right here. If you happen to have the ordered pairs for the vertices, your second option involves just altering those ordered pairs. This only works if we're going to be going around the origin. All right, so we have ABCD. I know that's my pre-image. It's in black in your picture because there are none of those little marks next to the letter, no prime marks. So I have my ordered pairs. A is sitting at 2, 3, over 2, up 3. B is sitting at 4, 3, over 4, up 3. C is sitting at over 5, up 1. And D is sitting at over 1, up 1. So they drew this on a piece of graph paper. And we want to do a 90-degree rotation. So I'm going to look right here at my rule. And for a 90-degree rotation, what it looks like is happening is I'm flipping my numbers. So instead of 2, 3, I'm going to make it 3, 2, and then I'm going to put the opposite sign on that first coordinate. So instead of 2, 3, it's now 3, 2 with a negative on the first coordinate. Instead of being at 4, 3, I'm now going to be at 3, 4, and I'm going to put the opposite on the first coordinate. Instead of being at 5, 1, I'm going to go 1, 5 and change the first coordinate to its opposite. And instead of being at 1, 1, I'm going to be at 1, 1 and change the first coordinate to the opposite. Now, if I were to go ahead and draw these out, this is what it would look like, and you would have your 90-degree rotation around the origin. So this right here is super helpful because you don't always want to draw it out and use your transparency. Sometimes you just want to know what the coordinates are. This is the try it for example number 2. It's about halfway down the page on page 323. And here's an example of when it would be easier to use the general rule than to actually draw it out and use your transparency. It says the coordinates of the vertices of quadrilateral HIJK are bam, 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 and bam. And we want to rotate it 270 around the origin so we can use those rules. And we only want to know the new vertices. So we're going to start off just copying these down. And then we're going to look at our notes. What I told you was going to be very helpful in example number 2. And we are looking for a 270-degree rotation around the origin. And it looks like what we're going to do is we're going to take our original, we're going to flip the numbers around and make the second coordinate the opposite. So instead of 1, 4, we're going to have 4, 1, make the second one an opposite number. All right, I'm going to have you pause me here. I want you to finish these and then come back for checking. All right, I'm going to go ahead and flip my numbers around and make the second coordinate the opposite. I'm going to flip my numbers around and make the second coordinate an opposite. I'm going to flip my numbers around and make the second coordinate the opposite. All right, I want you to check your work. If you had that right, I want you to give yourself a star. All right, example number 3. Now we're going to describe the rotation. So we started off understanding rotations. That was example 1. Example number 2 was we created a rotation. And now number 3 says we've got this rotation. Now let's talk about what's happening. All right, so we know we have the origin. I also know, as the origin is my center of rotation, that's my pivot point. I know this is my original because there's no prime marks. So it looks like we're going 1/4, 2/4, 3/4, counterclockwise. So there's 2 ways of saying this. I can go 270 degrees counterclockwise, or I can go 90 degrees clockwise. Remember, in a circle, there's 2 ways of getting where you're going. So the first one I showed you in red. My other option was I could have gone 1/4 of a turn this way. All right, now, one thing that I want you to notice is if it's going to be clockwise, they're going to call it a -90. If they don't have the label clockwise, you're going to know it's clockwise because it will be negative. If they have the word clockwise, they'll just put the number. All right, this is example number 3 on page 323. Describe the rotation that maps this original onto the image. All right, so let's go ahead and look at G. I like G as the first number or the first vertice. If I'm thinking about a compass, this might be my southernmost coordinate. And it looks like I'm moving it 1/4, 1/2. Instead of being south, it's now north. Sometimes using a compass helps me remember how many turns I've done. So I went to the east and now I went to the north. That is a 180 degree, 180 degree rotation. Now this one doesn't matter if it's clockwise or counterclockwise because it would also be a 1/4, 2/4, or a 1/2 turn that way. So I'm going to call this clockwise, and I have to know where my pivot point is, about the origin. Now you could have traced the red figure and you could have physically moved it. You could have put your pencil on the pivot point and moved it 1/4, 1/2. That also will work. If you're unable to visualize that, then use that transparency. This is your key concept on the top of page 324. A rotation is a transformation that turns a figure about a fixed point called a center of rotation. The angle of rotation is the number of degrees the figure is rotated. The x and y coordinates change in predictable ways when rotated. And here it is again. This is super helpful for you. So there are 2 ways to rotate. You can physically draw on your transparency, put your pivot point down with your pencil, and turn the figure. That is okay. The other one is to use these general rules right here to figure out your new set of vertices.